Okay, now we're moving on to the trig aspect of the chain rule. And you're going to use the chain rule anytime you have an inside function. And at this point, looking at this cotangent function you see on the screen, you no longer have cotangent of x. You have cotangent of some more advanced expression, and you're going to have to use the chain rule. Now when I use the chain rule with trig, I consider this three different pieces. I call it power, trig, and angle. And when I do these derivatives, I use this little notation, PTA, every time. Now, for this particular one, there's no power, so I'm going to strike through this part. If there was a power, it would be right here where I just put that blue 2, but it doesn't have one. But if it does have a power, that's where you're going to start. This one doesn't have a power. Okay, so it doesn't have a power, we'll move on to trig. So the trig portion is cotangent. The derivative of cotangent is negative cosecant squared. So you're going to say negative cosecant squared of the angle. What I want you to notice about that piece is the only part that I took care of was the derivative of cotangent. Everything else I recopied. So all I changed there was the derivative of the cotangent. Now then, for the angle portion, I'm going to take the derivative of only the angle. I'm going to take the derivative of only this blue part at the top. The pi over 2 is a constant, so that derivative is 0. Pi x, that's just a regular linear function. Pi is your derivative. That's the coefficient of x. So this particular answer, when we clean it up, would be negative pi cosecant squared of pi x minus pi over 2. And that's what it would look like. Okay, so let's move on to some other ones. Okay, so here's my next one. I want to find the derivative of tangent. I'm going to use power, trig, angle. Okay, this particular trig function has a power. It has a power. So what I'm going to do is just your basic power rule. All I'm dealing with is the power. So if you take the derivative of tangent squared, you're going to say 2 tangent to the 1 x. Now, all I dealt with there was a power. That was it. So that was my first step. Basically, you can also think of it like this. I took care of the 2. Bring the 2 down, decrease it by 1, don't touch anything else. The second step that I'm going to do is I'm going to take the derivative of the trig. So the derivative of tangent is secant squared. So this would be secant squared of the angle, and the angle here is x. That takes care of this piece. So the last piece is the angle. Well, this angle is just a plain angle of x, so the derivative of x is 1. But had it been more advanced, of course, you would have to take that derivative. So cleaning this one up, your derivative of this function is 2 tangent x secant squared of x. Let's try another one. Oops, went too far. Okay. Power, trig, angle. Your power here is 3. That's the only thing that I want to alter. 3 secant squared 2x. Okay, I took care of the 3. The next thing I need to take care of is secant. The derivative of secant is secant tangent, but remember you want to keep your angle. So the derivative would be secant of the angle, tangent of the angle. Now Now the way that I got that again was the derivative of secant is secant tangent. I just kept the angle. The last piece is the derivative of the angle. This angle has derivative 2. The 2 and the 3 out in front can be combined, so your derivative for this function would be 6 out in front. You have a secant squared and a secant, so that would give you secant cubed of the angle. Let's fix that. Secant cubed of the angle, and there's 1 tangent. Let's try one more of these. So here we go. I have a cosine squared. So just taking care of the 2, this would be 2 cosine to the first of 4x plus 1. Okay, let me fix this. Okay, try that again. Now, trying that again when my pen is working, sorry for that trouble, I'm going to bring down the 2. 2 cosine 4x plus 1. When I decreased my power by 1, 2 minus 1 gave me a cosine to the 1 there. Okay, so the trig part of this one is you're going to take the derivative of cosine. Well, the derivative of cosine is negative sine of the angle. Then you're going to take the derivative of the angle. So the derivative of 4x plus 1 is just a 4. Now that's how it would look. We need to put that together and simplify it. Be extremely careful with a negative sign. That does not mean minus sign as in subtraction. That's a negative 1 times the sign. So when you're cleaning it up, if you take all your coefficients to the front, you have a 2 and a negative 1 and a 4. So that's negative 8 cosine of 4x plus 1 sine of 4x plus 1. And that's how it would look.